So this is a common pitfall to watch out for. That is, you have a derived class that inherits inherits from a base class, which has private data members. The derived class does actually get all those private data members, but we cannot access them directly. Not even through derived class member functions. So what do I mean by that? So if you were to look at the employee class that we were looking at in the last couple of videos, it has 3 private data members: name, social security number, and net pay. And then we have, in our code, we actually use it. So if you were to try to get at name inside a method in the derived class, you would think you should be able to do that because we inherit salaried employee. This class does actually inherit from the employee class, but however, remember that the name data member is private. So if you compile this, you should get an error message if you try to access a private data member of the base class. Instead, you have to use getName. So even though this method printCheck belongs to a subclass or a derived class of the base class, it cannot access private data members of the base class, which is how it should be. So as a result, you have to use a method, accessor method, and then everything works. If we spelled everything right, okay, there we go. Okay, so if you have a member function in derived class, you cannot access private members of the base class. Private member variables can only be accessed by name in member functions of that base class itself, of the base class they're defined in. Okay, so what if you have base class private member functions? The same rule holds for base class member functions. You cannot access private base class member functions in the derived class member functions. So it's a little bit hard to read, but what this is saying is that you cannot access any private data member or member function outside the interface and implement.h and .cpp files of the base class. Okay, so you cannot access private member functions in derived class member functions, which is all, that's how it should be. That's the same in Java. So if you remember your Java rules, that they work here. Base class private member functions, if you have private member functions in the base class, that has sort of a larger impact than member variables. Why is that? Because member variables, you can access them typically through accessor or mutator, that is get or set member functions. However, for member functions that are private in the base class, there is no alternative, right? They're just simply, these private member functions are just simply not available in the derived class. So this has, for private member functions, they have a larger impact than member variables, because there is a second way to get to member variables, that is through get and set methods. This is reasonable. This is how you want things to be. Private member functions should simply be helper functions for the base class. Okay. So there is a third visibility modifier that is protected. So far we haven't used it, but let's just do a simple example. So for example, we wanted to get the name of the employee, which is a member in the superclass. So we should be able to do this, but we can't. But here's one way you could do this, is if you go to employee.h and make this, for example, protected. So what protected means is that in any base class, if you have protected in a base class, then in a derived class, that these data members will be visible. It's as if you have almost like public access in the derived classes. I guess another way to say it would be, a better way to say it, I guess, would be if you make something protected in the base class, that means you're giving visibility to these data members in any derived class. It's probably a much better way of saying that. So now we can compile this. We should have no errors. Okay, so let's go back to our print check function. Here's where we use the data member, and we can do the same thing with net pay and social security number. I don't remember what the exact spelling of these things are. Name, net pay, and social security number. All right. There we go. Save it, compile, and this time around it'll work because we made them protected. Okay, so I'm going to undo these because we probably shouldn't. It's not a good idea to use protected. If you can avoid it, do it. The rule of thumb, as in Java, is that you should always make all your data members private unless there is a really good reason not to. And in this case, since we provide set and get methods, there really isn't a good reason to change this from private. All right, so let me just recompile everything, make sure it works. Sure enough, okay, worked. Okay, so making something protected, that's it's new. That is, we haven't looked at. We only looked at private and public so far, and so. But those of you, if you've had Java, you've seen this before. You've seen the protected visibility modifier. So this allows access by name in derived classes, but nowhere else. If you have an unrelated class, you cannot get access to protected data members. So nowhere else in other classes that are not related to this class employee, let's say employee.h, the class employee, they cannot. Other classes cannot access protected data members. Same as in Java. In the class it is defined in, it acts like a private. So this is considered protected in the derived class. I guess that's a much better way to think about this. And this allows future derivations. So that if you have a subclass, a new subclass that extends a base class, that is a new derived class, then you can access data members in that new class. According to a lot of programmers, object-oriented programming people, a lot of people think that this violates information hiding. The basic idea of information hiding is make everything private, make it not be accessible. Even if you have inheritance, a lot of programmers will make everything private. That said, I think there are a lot of situations where it helps to have things be protected as long as you're doing the right thing, and that's the big if. Oops. If you're doing the right thing, probably okay. In Java, we talk about subclasses overriding some functions from the superclass. Here, we use slightly different terminology just because in Java there was only one kind of method. All methods were virtual, and we'll get into more details about virtual functions in the next chapter. But I just want to quickly say, because of the fact that C++ has the capability of having virtual or non-virtual functions, we don't use the same kind of term as in Java. That is, we don't say overriding. We use it only in some occurrences, and you will see the term overriding in the next chapter. We usually use redefinition of member functions. So in the interface of a derived class, we can have declarations for new member functions, and we do in hourly employee, for example. We have some brand new functions. Let's get hourly employee.h, for example. We set up some brand new functions which we did not have in the superclass or the base class, but then we do have a redefinition of print check. Okay, so we saw print check in employee.h or in the employee class. It just sort of quits the program. Here, this one is the one in the derived class, hourly employee, and the salaried employee. That's meant to be used, and so those actually do work. That is, they do something useful. So you can also contain declarations for inherited member functions that have to be changed. So in the print check is one of those. Inherited member functions, if they're not declared, they're automatically inherited unchanged from the base class. And so all of the things like get name, things like that, we use. For example, this get name comes from the base class. So also the get net pay and the get social security number. They all come unchanged from the base class. Okay, so the implementation of the derived class will define new member functions and redefine inherited functions as declared. So there's a big difference between redefinition, which is like overriding but not exactly, versus overloading. Remember, in Java, overriding, overloading are two different things, very different. Same thing here. Redefining in derived class has the same parameter list as the method or the function in the base class. It rewrites that function so that it does a completely different thing. Overloading, however, works differently. It has a different list of parameters. That is, it has a different signature. That's the technical term we use. Overloading is when we have two functions, member functions with different signatures. You can have a new function that takes different parameters. That's still overloading. So if you have a base class member function, add, and if you have a new function in the subclass or the derived class that takes different parameters, that's overloading. Overloaded functions must have different signatures. And remember, the signature is the name, is a combination of the name of the function plus the sequence of types in parameter list. So the order is important, the number of parameters is important, and the types of parameters are also important in determining the signature. Signature does not include, in C++, does not include the return type, use of const, or ampersand. Okay, so here's a thing that's different in C++ and Java. If you redefine a function in a derived class, it turns out in Java you don't really have access to that base class definition, base class member function. The thing that you redefine from the base class, that is lost. Here in C++, if you redefine a member function of a base class in a derived class, the base class definition is actually still around. You can actually access it, and you can use it. You can access it using the : scope resolution operator. So here's a simple example. You have Jane E is an instance of employee, Sally H is an instance of hourly employee. So you can call the print check function of both. That's fine. So this calls the print check function of employee, which would actually cause the program to quit, so you don't want to do that. But this one should work. Now, as Sally H is an instance of the subclass or derived class, you can still call the print check function of the base class by using the base class name and the scope resolution operator. Okay, so that said, you don't want to ever do that, or you should never have to do that. But every once in a while it might come in handy. So try to avoid it.